So chapter 3 starts with describing data, numerical measures. In the previous chapter, we learned how to construct and interpret visual or graphical statistical measures. Oftentimes, however, data is summarized as numeric information. In this chapter, we will explore various ways of describing central tendency and variability in data using numerical measures. We'll see demonstrations on how these measures are computed. Here are our learning objectives. You can also find these in your textbook. Parameter versus statistics. In solving many of the problems in the succeeding chapters in this textbook, it's important for us to be able to distinguish the difference between the two terms parameter and statistics. In addition, you need to be able to determine whether a given information in the problem is a statistic or a parameter. The correct application of many of the formulas introduced in this textbook requires correct identification of these types of summarized information. We define parameter as a measurable characteristic of a population, while a statistic is a measurable characteristic of a sample. A statistic, also known as a point estimate, is used as a way to estimate the population parameter. As we learned in chapter 1, a sample is used to study a population characteristic. Oftentimes, we are interested in finding the center of the distribution of data. For this, we choose from a number of measures of location. The most commonly used ones are the arithmetic mean, weighted mean, median, and mode. In the following slides, we will define each of these measures and demonstrate examples of each as to how they are computed. We will also learn the advantages and disadvantages of each measure, or when we would prefer to use one over the other.